Dear students, in this video, I'm going to provide you the, the formulation of different formulae, the derivation of different formulae. So started with this interpolation. So here we have already aware about the data types. So we are having this type of data. Now aim is to find out f of x and this within this range. So first aim is to find out f within this range, which is interpolation, and here we are aim is to try to find out this interpolating polynomial. We know about this, so this is written here. Interpolating polynomial means, suppose this is the data pattern which is already, so if this is the actual curve, these are the values, so now aim is to find out a new function which is approximation of this. This is our phi of x, this is f of x, this is interpolating polynomial. We have already about this. So now aim is to find out this phi of x, for which we are having different formulae. So these are the formulae. So depending upon data type, if we are having data type of this kind, that means fixed step size, then we are having these 6 formulae. First method is Newton's Gregory forward interpolation formula. Second method is Newton's Gregory backward interpolation formula. This is for forward, this is for backward, and rest of these 4 are for central differences. Here is the Gauss forward interpolation formula, Gauss backward interpolation formula, Stirling's interpolation formula, and Bessel's. They are for central differences. This is for backward, this is for forward. On the other hand, if data type is this, here we are having variable or unequal step size. The difference between x0 and x1 is not as it is same as the difference between x1 and x2. They are unequal. So variable step size. So here we are having 2 methods. One is Lagrange's interpolation formula and another one is Newton's divided difference formula. Fine. Now we will derive these formulae one by one. So here is the first one. Here is the first one. Here is the first one. So here we are having fixed step size, and suppose data is this: x0, x0 plus h, x0 plus 2h, x0 plus 3h, x0 plus nh, and these are the corresponding values in terms of f. So how many data points are there? N plus 1. These are total n plus 1 data points. N plus 1. These are total n plus 1 data points. So here first we are deriving Newton's Gregory forward difference formula. So for given n plus 1 set of data points, since n plus 1 data points are given to you, so we can easily fit a polynomial of degree n. So we can fit a polynomial of degree n. So one way of assuming this polynomial is this. Suppose this is f of x or phi of x is equals to some a0 plus a0x plus a1x plus a2x square plus an x raised to the power n. This is one way, but this is difficult. Why? And another thing is that this is very difficult to evaluate all these values with the help of given data. And here we have not assumed the interpolating condition. We know that what is the interpolating condition? Interpolating condition says that f of xi is equals to phi of phi of xi when I is 0, 1, 2 to n. We have not taken care of this. So during this assumption, we have to consider this part also, and also take care of the simplicity of the calculation. So that's why rather than taking this, we will take f of x, or we will assume f of x as this. Here we have assumed we are taken care of the interpolating conditions. Fine, and you will see that this is more simpler than that. So let us say f of x is a naught plus a1 x minus x naught, which is the first point. So x is a variable, x minus x naught. Then a2 x minus x naught and x minus next value x naught plus h, which is here, plus a3 x minus x naught, x minus x naught plus h, x minus x naught plus 2h. So we are getting this, and so on. So an is x minus x naught, x minus x naught minus h, x naught minus x minus x naught minus 2h, and last is, because if you are writing a2, then the last one is, for a2 last is x naught plus h. Similarly, when you are writing for an, so last value will be the previous term, second last term. So x minus x naught minus n minus 1h. Fine. So this will be the construction. Here aim is to find out a naught, a1, a2, an, a3. This to be determined with the help of these values. With the help of these values. So we will put one by one x naught plus h, x as x naught plus h, x naught plus 2h, x naught plus 3h, and so on, and we will find out a naught, a1, a2, a3, an. Fine. So first we will put x equal to x naught. What we get? Put x equal to x naught, so this will be 0 because we are having a factor of this kind. This is factor is available here also, so all these terms will be 0. So what we get? F of x naught is a naught. So a naught is evaluated very easily. Similarly, put x equal to next value x naught plus h, x naught plus h. So what we get? F at x naught plus h is equals to a naught plus a1 x naught plus h minus x naught, and this will be 0 because one factor is available here. This factor is also available here or in the rest of the term, that's why they will be 0. So f of x naught, because a naught is, we have already evaluated, f of x naught plus a1, and this x naught is cancelled out with this x naught, so we get h. So from here we can easily find out a1. A1 is nothing but f of x naught plus h minus f of x naught divided by h. But this is nothing but the forward difference. Using the forward difference, this can be written as delta f of x naught by h. So now we have a naught and a1. Now put x equal to next value x naught plus 2h. So after simplification, so here we get, put x is equal to x naught plus 2h, x naught plus 2h is equals to a naught plus a1, x is replaced by x naught plus 2h, so x naught is cancelled out with x naught, so we get only 2h, plus a2, and after simplification we get 2h into h, and this will be cancelled out because due to this factor, and similarly remaining factors will be 0, so we get only a2. So after simplification we get f of x naught plus 2h is equals to f of x naught, because a naught is f of x naught, plus a1. A1 is from here is delta f of x naught by h. So when you are substituting, you will get 2 delta f of x naught plus a2 into 2h into h, 2h square. So from here a2 is evaluated 1 by 2h square, this value minus this value minus this value, so they are written here. Now here we have taken f of x naught plus 2h minus f of x naught minus this value. So you can, here is the forward difference operator. So the value of delta f of x naught is nothing but f of x naught plus h minus f of x naught. So substitute this value, so we get this result here. So we get f of 1 by 2h square f of x naught plus 2h minus this value here. Fine. So we will bifurcate this into two parts. One is here, one is here. So minus f of x naught plus h minus f of x naught plus h, and this is minus f of x naught plus this is 2 f of x naught. So the resultant will be f of x naught only. So this is written here. So this is the value, and then this can be written with the help of forward difference as delta f of x naught plus h. Similarly, this can be written as delta f of x naught. So here is the values. Again apply forward difference, second order difference. So this is nothing but delta 2 f of x naught divided by 2h square, which can be further rewritten as delta 2 f of x naught. This 2 can be written as factorial to h square. Similarly, we can find a3 and an. So these are the values. Substitute all these values in the formula here and we get this result here. Fine. Now to simplify this representation, we will take one transformation, because in each factor you can see that we are having a term x minus x naught by h, x minus x naught by h, x minus x naught by h, and so on. So let us suppose that x minus x naught by h is a new variable u. So from here x will be x naught plus uh. Substitute this value. So here is x. So x can be written as x naught plus uh is equals to f of x naught plus x naught, x minus x naught by h is nothing but u. So u delta f of x naught plus, similarly here this is u and this again. So just divide this quantity by h also. 1h you can take here and 1h can you take here, and after division this will be nothing but x minus x naught by h minus 1. So that's why u minus 1 delta 2 f of x naught and so on. So this will be the overall formula. This is the Newton's-Gregory forward difference formula. Fine. Now next formula is Newton's-Gregory backward interpolation formula. Again we are having same data points. Again we can fit a polynomial. Here since our target is backward, in the previous our target is forward, and that's why we have started with in forward direction here to here. However, in backward we will start our procedure from the last. So we will start from last and we will move towards the starting or initial value. In previous approach we will start from start to end. Here we will start from end to top. This is the difference of the approach. So here f of x naught is a naught plus a1 into this value, x minus x naught minus nh. a2 will be its previous value, x minus x naught minus nh into x minus x naught minus its previous value will be x naught plus n minus 1h. So written here and so on. So an will be, so we will move from here to here because they will be total n plus 1 data points. So an contains n factors. So x minus last factor will be x naught plus h here. So this is equation number. Now aim is to find out a naught, a1, a2, an. Again we will use the same approach, and with the help of that approach we can find out the values. So this is here. So just put the values x equal to x naught plus h, x naught plus n minus 1h, x naught, and we will get the values of it. So just put x equal to x naught plus nh, last value of the data, so that we will get the value. This is the data. So put x equal to x naught plus nh. So here we will substitute the values and we will get a naught. A naught is f of x naught plus nh. Similarly, put x equal to x naught plus n minus 1h, second last value, and then find out the, and here we will not use forward difference operator. Here we will use nabla, backward difference operator. Fine. So here a1 is this, but with the help of nabla this can be written as nabla f x naught plus nh by h. Similarly, we can find out a2, a3, an in terms of nabla and then substitute these values in equation number 1. So we get this value. So we get this value in terms of nabla. Again we will utilize the transformation, because in each term we are getting this x minus x naught minus nh by h. This factor is available in each. So that's why we will assume that x minus x naught minus nh by h is u. From here x is equal to this value, substitute this value, so finally we will get this formula. Fine. Now we will take a simple example. Suppose this data is given to you. Aim is to find out f at 1895, f at 1925. So here we will apply both these formulae, forward as well as backward. Fine. And remember one thing, table is always same. Either you are applying forward, backward or central difference, table is always same. So here we have constructed the forward difference table or backward. You can say this is a backward also, this is the central difference table also, because we are having same table. So here x is 1891 up to 1931, corresponding values of f are listed here. Then find out the differences. First order difference is written here: 66 minus 46 20, 81 minus 66 is 15, 93 minus 81 is listed here, 101 minus 93 is 8. Second order difference will be 15 minus 20 minus 5, 12 minus 15 is minus 3, 8 minus 12 is minus 4. Similarly, third order difference: minus 3 minus 5 is 2, minus 4 minus 3 is minus 1. And then fourth order difference: minus 1 minus 2 minus. Fine. Now, since our target is to find out this value, and you can see in this table, this value 1895 is near about the top of the table here, nearby top of the table. So we will utilize forward difference operator, because our target is not only to find out the value, but also target is to cover up maximum number of columns. And this will be possible only when if you are applying forward approach. For example, if you are applying the backward approach, so you will cover up only one or two columns. But if you are applying forward approach, then you will cover up maximum number of columns. So this is you have to look after. Fine. So here our aim is to find out this value. So suppose this value is nothing but your x naught. X naught is the starting value. X naught, x1, x2, x3. X naught is the starting value 1891. Differencing is 10. So h is 10. And our aim is to find out f at this value. So this is your x. X is 1895. So now what will be u? In forward difference method, u is nothing but x minus x naught by h. Substitute the value 1895, because x is 1895, minus x naught starting value 1891 divided by h. So we get 0.4. U is 0.4. So formula, Newton's Gregory forward difference formula is written here. Substitute the values. So here first value is f of x naught. So here is f of x naught. So here f of x is obviously 1895 is equals to f of x naught. F of x naught is the starting value. This is 46. So 46 plus u is 0.4. Then first order difference in this movement, in this direction. So you can say that nearby 1895 we have 1891. That's why we will take all these values. If suppose we are finding the same, we are utilizing same table, but 1890 for 19 for sorry, if we are finding f at 1900, then the closest one is 1901. So we will take the second row. Fine. But here since 1895 is unknown, which is close to 1891, so that's why we are taking the first one. So here this plus into delta of f of x naught, which is 20 here. So write down here 20 plus then u into u minus 1, that means 0.4 minus 1, and second order difference, which is minus 5 divided by factorial 2 plus u into u minus 1 into u minus 2. So 0.4 minus 1, 0.4 minus 2, multiply by the third order difference, which is 2 divided by factorial 3, and last is u into u minus 1 into u minus 2 into u minus 3. So 0.4 minus 1, 0.4 minus 2, 0.4 minus 3. Fourth order difference, which is minus 3. So minus 3 divided by factorial 4. Simplify this calculation. What we get? We get this result. Okay. Now the second one is f at 1925. If you look at the table, 1925 is somewhere here. So both are close to this number. So if you use this table, then you have to take the second last values in each column, and you will cover up only 3 columns. That means this column is left out, which will create the error. So to cover up all the columns, better is to use 1931, so that you can utilize all the values. Fine. So this fine, and now we will use the formula. So formula is here, x naught plus nh. Last value in this table is 1935. This is x naught plus nh. So x naught plus nh is 1931, h is 10 differencing. Now the desired value of x is 1925. So substitute this value to find out u is nothing but, for backward difference formula, u is x minus x naught plus nh divided by h. 1925 desired value minus 1931 divided by 10, so minus 0.6. This is the formula. Substitute the values accordingly. So here we will start from the last value. So f of x naught plus nh is 101, last value, this 101. Then first order difference will be this, second order difference will be this, third order difference will be this, and last order difference, fourth order will be this. So substitute all these values here and value of u, and after simplification we get this result. So this is the procedure. Fine. One more example is written here. Here we have data in terms of range. So the following table gives the marks secured by 100 students in numerical methods subject. Range of marks is 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80. And number of students is 25, 35, 22, this is 22, 11 and 7. Use Newton's forward difference interpolation formula to find number one, the number of students who get more than 55 marks. Second, the number of students who secured marks in the range from 36 to 45. Fine. So I think you have understood the problem. So now first we have to construct the table. So here range is already given to you, 30 to 40, 40 to 50, 50 to 60. So here we will construct the table in this form. So marks obtained less than x. So if marks is less than 40, then here we are having 25 students. Marks is less than 50, we have how many students? Less than 50. Take the sum of these two, 25 plus 35. That means nothing but 60. Marks less than 60 means sum of 25, 35 and 22, cumulative sum. So likewise we can construct this table. So marks less than 40, 25 students, marks less than 50, 60 students, now marks less than 60, 82 students, marks less than 70, 93, and marks less than 80 is 100 students. Sum of all these students is 100. Now find out the first order difference. 60 minus 25 is 35, 82 minus 60 is 22, 93 minus 82 is 11, and so on. Similarly, second order difference, third order difference, and fourth order difference. Fine. Now in first problem, number of students who get more than 55 marks. This is our problem. Fine. So 55 is nearby this here. So we will apply forward difference formula. So here x naught is 40 starting value, h is differencing is 10, and desired where we have to find out the value is 55. So now u is equals to x minus x naught by h for forward difference, Newton's Gregory forward difference. Substitute the values. 55 minus 40 by 10 is 1.5. Then this is the formula. F at 55 is equals to f of 40 starting value plus u delta f of 40 plus u into u minus 1 divided by factorial 2, the second order difference at 40, and so on. This is formula. Substitute the values. So first value is 25 plus u is 1.5 into first order difference, which is 35. So 35 plus u into u minus 1 divided by factorial 2. So 1.5 into 0.5 divided by 2 into second order difference, which is minus 13. So minus 13 plus u into u minus 1 into u minus 2. So 1.5, 0.5 minus 0.5 divided by this. So 6. Third order difference, which is 2. So 2 plus this. So this is already listed here. After simplification, we get this. But here we are finding the number of students. So they cannot be in fraction. So that's why approximately 72. So this is the number of students who are getting marks less than 55. So there are 72 students who got less than 55 marks. Who got marks less than 55 marks. Fine. Now the next problem is to find out the range who secured marks in the range from 36 to 45. So here is this second problem. So first find out f at 36, f at 45. So again apply the same approach. X naught is 40, x is now 36, h is 10, u is now different. Apply the same formula, same table, then we are getting 8. This value is 7.864, which is approximately 8, because here finding the number of students. Similarly f at 45 here. So here is same. Now x is now 45. So u will be now 0.5. Apply the same formula. So we are getting 45.4.5, which is approximately 44. So the desired number of students is nothing but, because our aim is to find out the number of students within this range. So just subtract f of 45 minus f of 36. 44 minus 8 is 36. So this is the desired number of students. Fine. I think you understood. And if you have any queries, then please note down, and once this lockdown is withdrawn, then we will discuss it. Thank you.